Hello, physics people. This is Miss Wythe coming at you, and I have got more data for our Voltaic Pile Lab. So if it didn't have enough time for you to finish in class, or if you didn't get to look at other results, I'm going to be running 3 versions of the lab. I'm going to do pennies with washers. I'm going to do pennies with foil, aluminum foil. And I'm also going to do pennies with nickels. And nickel is actually a coin that is named after the metal it's used with. So we don't call these coppers, we call them pennies. But nickels are actually made out of nickel. So we'll be having 3 versions available. I have made one change in the lab. Instead of using paper towels, which I don't have at home, soaked in our ion solution, I used 3x5 cards, so a little bit thicker cardstock, and I've had them soaking in a little basin here. You'll see as I assemble them. And so for those of you that didn't get to use the multimeter in class, I'm going to be can you see that right there? I'm going to be turning it on, and we're going in this range looking for voltage, and we're going with the smallest one in the 20 range. So right now it doesn't say anything. If I wanted to measure amps, I'd be over here towards the A. If I wanted to measure resistance, I'd be over here towards the ohms. Not sure what these do over here, and off is up at the top. So I'm going to be running that. I'm going to move my camera angle now down to look at what I'm doing with my hands. It's probably going to be upside down, but in the end I will flip the data all around. But this is my setup. You're in my kitchen that is messy. Welcome. Have a good time here with me. So I'm going to scroll down here so you can see what I'm doing. So my multimeter pops on. I'm going to make sure everything's out of my way here. Tech-wise, bang around, make some noise. First one I'm going to do is the pennies and the washers. So if this is the one that you did in class, great. The washers that we're working with are made out of zinc. So it's actually steel zinc coated. So it's zinc on the outside. Pennies, if they're made after like 1980 something, actually are zinc on the inside mostly, and then just copper plating around the outside. So that that's just a little fun fact for you. So I'm actually going to start with the penny on the bottom. I'm going to use some of the cardstock here that is soaked, and then I'm going to put that on penny, and then washer on top. And then we're going to use our voltmeter. The plus or the minus that you get here won't matter. How about I actually turn that upside down so you can read it as data gets collected. Square away. And then I'll also be recording on here, and I'll flip this over once we're done so we get all of our numbers. So if I add this down here and there, 0.8, I'm okay with that. Okay, and we're just gonna keep layering. Oh wait, let me not, I counted all my things. Let me get those out of the way. So we're gonna go another penny, another piece of paper with our ionic solution, and another washer. This is gonna be real exciting to watch, right? Straighten it out. 0. It's jumping around a little. Let me go over here. I'm shifting my stack as I do this. I'm trying to keep it all assembled. Well, that's very small. Penny near the edge here. 0.78. I'll take that. Another penny. Another paper. Should have some background music for you for all the excitement that this is. I may not have this film the entire time. I may let it stop and then you guys can jump in at the end. Oops. 0. Should actually be getting higher, but of course we're not. 0.7. I'm gonna let it run with it, see if I kind of even out here towards the end. I've also got some pretty sad looking pennies for some of these. I don't know if that matters, but we'll find out because my pennies I got to work with the nickel are a whole lot cleaner and newer. All right, so this one, 1.31. Yeah, that's a nice jump there. Keep going. Penny, paper, washer. I'm kind of squishing it down each time to make sure. Oh, as now I hit in. Make sure I got good contact. 1.3. It's kind of the same as the last one. Oh wow, 1.9, 2.0, 1.7. Oh, 1.7. Penny, paper, washer, $1.9, 1.98, 2, 1.99, 2. I'll call that 2. So at 6 stacks, we're at 2 volts on a battery. Penny, paper, flattening it down, washer, 2.3. Rather than holding the electrodes on there for a long time, I'm just touching and moving on. We don't have the time, and you don't really want to watch me sit there, watch it jump around. And we don't really have any insulation around this Voltaic pile, so we could be losing electrons kind of outwards that way. So this is the 8th stack, 2.4, 2.6, call that 2.6. 9th one. Oh, that's a real sad looking penny. Let me get one. Try that one. This is also sad, but I'll put it paper side up. Paper. Copper. Give it a squish. 3.7. Okay. Wow, really? 3? Yeah, 3.9, 3.8, call it 3.8. So this is pennies and washers. I'm on my last one, number 10, penny, paper, and the 10th washer. So these washers are made out of zinc. Pennies have got a copper coating on them. Okay, oh, it's starting to tip over as I do this last one. 4, I saw 4. I think I was separating it. 3.99, 4, 4.1, sure, 4.1. All right. So I'm gonna display some data here. If this is backwards, I'm sorry. I think that's how the videos work. But here we have pennies and washers. 1 penny through 10 with washers, so 1 layer, 2 layer, 3 layers. If this is all backwards in the video, I'll take a final photo at the end and put it in the module. But you can see increasing voltage. So our voltaic pile that contains pennies and washers. I feel like an Instagram modeler here. Here's the light, there you go. Pennies and washers with the ionic vinegar solution inside between them. We are going almost up to 4 volts, so 4 volt battery right here. So I'm gonna leave this stacked because I'm actually gonna try to model something at the end. As exciting as this is to watch, I'm only gonna do a couple of the penny and the aluminum and a couple of the penny and the nickel. Can you do them side by side? So you can see if there's a different kind of trend. So I'm gonna put the penny and washer data to the side. We're gonna go back down here. So now, we're gonna do pennies and aluminum foil. So we're gonna go penny, paper. So instead of zinc, we have aluminum. So copper and aluminum now. Aluminum. Okay. I'll leave the room here to record. Probably have another color, so you can be looking at different things. Okay, so penny, paper, foil. So we have this kind of layering now. I'm gonna put it all down. I'm gonna try to get under here. So 0.23. I'm gonna do one more penny. Maybe go like halfway to like 5, and then I'll build them all, get you all the data up to 10 for each of them. I'm just not gonna film the whole thing. Okay, so 2 stacks, aluminum and copper, 0.55. 3 stacks. Oops. Everything's going every which way here. I've also, I should say, just to make the aluminum a little easier to handle, I've actually folded it so it's like 2 or 3 pieces of aluminum. So we not only have thicker cardstock holding more solution, but I've got thicker pieces of foil than just one. I found it a little flimsy in class today. 0.44. So again, down a little. So it feels like we have a weird trend early on where the battery's not sure if it wants to really like go or not. But that's okay. Sometimes you can't decide what you want to do. Maybe paint happy little trees. Let's see. Okay, so I'm gonna give it a squish. That helped before. Give it a squish. Touch it. 0.76. And I'll go to 5, and then I'll do 5 with the pennies and nickels, and then I'll pause the video and we'll get to the end and have the data for all of them as a picture. There's one thing I want to show you though with the penny and washer one before we're done, if it can do it. 0.7779, 0.757472. This one feels like it just didn't want to go either. I'm also spinning it around. .6, sure, jumping around a little. Okay, so far we got a little bit of an upwards trend for pennies and foil. I'm gonna move that to the side, dirty counter, and I'm gonna do pennies and nickels. So copper metal and nickel metal. So pen in the bottom, nickel. And let's see, I had one more paper here for that. Another pen. Purple, sure. All right, so penny and nickel. Hang on, hitting the paper towel. There we go. 0. Oh, this looks less exciting. 0.01. I feel like I can predict that penny and nickel might not be as voltaic, but I might be wrong. Let's find out. 0.08. Yep, seems to be the slow horse here. So we'll go to 5 and we'll see what we get. Penny, paper, nickel, and I'm squishing it to get out kind of any air bubbles so that it really gets a good seal top to bottom. 0, oh, here's a jump, 0.3, 0.4. Penny, paper, wonder if it matters, heads or tails. 0.6 volts. Oops. Penny, paper, nickel. Here's our 5th one, so this will be the one that I stop here. 0.77879. Called 8. 0.8. All right. So I'm going to keep going on all of these so that we get 10 together. And again, sorry if I'm showing this in the video and then they're just backwards numbers, but we've got penny with aluminum foil, and we've got penny with nickel metal up to 5 layers. I'll go ahead and collect the data down to 10, but I wanted to show you what we've got here. So I have the original one, this battery of 10 layers of zinc and copper. And at that one, we ended up having a total of about 4 volts total. So that's bigger than a regular battery. And I'm gonna see if it can light a light bulb. So I'm gonna get my hands on this. These are little switches, so it'll turn the light bulb on and off. It's kind of like a light switch. And the little circle part here is where the light bulb's gonna fit. And I've got some alligator clips, so I'm gonna see if I can get this to actually turn the bulb on. I'm probably gonna have to put the bulb on the kitchen countertop and then lift the battery in my hand so I can hold the clips on either side. But I'll show you what I'm doing. Okay, and can I zoom in at all? No. Trying. No. Okay, we'll go with what it is. So I'm gonna clip on to the leads here. I'm gonna not have it fall to the ground. And if I have a battery, wait, I do. I'm gonna get you one on the side here. Okay, this is your regular AA battery from Costco. And these on the side, 1.5 volts is what they say. So that's just labeled on the side of the battery, typical AA. So if I measured the voltage of this battery and connect one end and the other, it's about 1.5, 1.6 at 8. It's actually charged up pretty good. So this battery's, you know, full power right out of the package. But the one we made here should be better. This one said it was 4 volts. So I'm actually gonna light the bulb first with the regular battery. And I'm gonna turn the lamp off just so we can actually see if this little guy's lighting. Let me turn off my upper lights. How bright this is with the lighting. There's obviously a nice big glare up above me. Let me adjust some more. Stand by. All right. There we go. Now nice dark and spooky. You can see the light if it's actually going to be turning on. So I'm going to connect the battery to the electrodes. And I hope I didn't bring a dead bulb with me. That'll be hilarious. Oh, now there we go. So light bulb turning on. So I'm just connecting the 2 electrodes to either ends of the battery. And you can see that battery is lighting up this bulb. So if I can do that with my Voltaic pile. So let's see. I'm gonna just hold this against the penny on the bottom and the washer on the top. Oh, come on, you can do it. Kinda good. Oh, this should have worked. What a letdown if I can't get this to go at the very end here. I'm trying to get it to have good contact. No. All right, well, I'm gonna keep working on this because it definitely should work. I've seen it happen. I might need more pennies. I might need more solution. My bulb isn't dead, but I know I can get it to work. So I'll work on this. Sorry about that letdown at the end here, but the bulb does work. So I could try the copper and the pennies. No, I only got 5. No? All right, well, we'll make it work. Maybe I need some kind of connector between the pile and the alligator clips. I'll work on that. So I'll get the rest of the data up. So look for a photograph in the module of the rest of the numbers. All right, thanks for playing. See you later.